Hello and welcome to our experiment. We are gonna prepare for our calcium chloride to be set aflame here. We have come with our safety precautions, which are our gloves in case of any chemical spills, long sleeve shirt, and denim jeans and closed-toe shoes just in case. We have also set up everything properly. We've got our candle set down. We've got our inoculated loop that's already been cleansed and has cooled down for 30 seconds. So we will continue with our procedure, which is to dip it in our solution, get a nice bubble, and then we'll set it aflame. And note for any color changes. There seems to just be a few orange sparks that come around from the outside of the flame. Once it's done, it's undone. Anyways, thank you so much and hope to see you next time.
One of the biggest safety hazards in this lab was the lithium chloride. It is the most dangerous chemical that we were working with according to the safety data sheets that we were provided. This chemical, if ingested, could cause a lot of effects to our nervous system, cardiovascular system, kidneys, and thyroid. It could also irritate our skin, eyes, and cause irritation to our lungs as well. I avoided contaminating our chemicals by making sure that every single item had its own respective working tool. It had its own container along with its own loop to avoid any possible contamination. One way that I would have been able to tell if I had accidentally contaminated was the way that I placed everything. Each container for the chemical was to the left of each of their loops, just to verify that every time that I used it, it was going to be to the right of the chemical. Which substance did I like observing the most? I think I enjoyed observing the most was the potassium chloride, as it had a more calm flame to it. As you can tell here in our observation, our potassium had a blue-violet hue to it. I think the most difficult to observe was the sodium chloride, as it didn't, our sodium chloride or our calcium chloride, as they both didn't really give off too much flare to each other. It had the same color as the flame, which made it really hard to observe. How did I observe the determined wavelength? I was using the specific tool that we had, and it was very hard to tell, but it was there to a degree. So for some of the resources that I used to gather some of my data for these chemicals was our eScience labs that was provided to us in the safety data sheets that we had. I went, and whenever I clicked on each site, it would populate one of these, which is where it gave us our entire data for each item. For this one particularly is lithium chloride, as it tells us the acute toxicity for oral, skin, and eye irritation as well. It gives us the information for its toxic traits, as right here it says inhalation of this material is irritating to the eyes, nose, and throat. Ingestion may cause rash, ringing in the ears, nausea, vomiting. Like, this was a very helpful site for when we were doing our lab report. It made it very easy to do and very easy to find stuff. And for certain ones that didn't populate all the way, I would use this one, the actual Science Interactive site, which helped as well as it also gave us most of the information for the ones that were missing, as some of them would not populate. It gives us everything that we needed and was particularly helpful. I believe these two are definitely some of the better sites for these things. I tried using a little bit of Google for some of the other ones, but because due to the nature that they're in the Aquay estate, it was not populating those specifically. It was populating the solid forms, which certain ones are a little bit more dangerous than others. And now for the last portion, which is to explain the process of writing the electron configuration for one of your metals in a salt compound used. How did you know it was right? Well, let's take a look at how to write the electron configuration for calcium, which is one of the metals used in our flame test, specifically in the salt calcium chloride. First, I start by looking up calcium's atomic number, which is 20. That means a neutral calcium atom has about 20 electrons. To figure out where these electrons go, I use the Aufbau principle. This tells me the order in which the electron orbitals fill up, starting from the lowest energy level, which is 1s, 2s, 2p, 3s, 3p, and then 4s, and so on. So counting up to 20 electrons, the full electron configuration for calcium is 1s to the power of 2, 2s to the power of 2, 2p to the power of 6, 3s to the power of 2, 3p to the power of 6, 4s to the power of 2. To simplify that, I can also use noble gases notation. I look for the noble gas right before calcium on the periodic table, which is argon. So the shorthand version is argon 4s to the power of 2. I know I got it right because I accounted for all 20 electrons. I followed the correct filling order, and the configuration ends in 4s to the power of 2, which is typically for elements in group 2, the alkaline earth metals like calcium. So that's how we write and confirm the electron configuration for a metal like calcium in a salt compound used in the flame test. Thank you.